Hey guys, this is Unit 6, and we'll be doing Day 1, Introduction to Logarithms. And in today, we're going to talk about the relationship between exponential functions, which we just got done with that unit, and logarithmic functions. Okay, so here we go. It says exponential functions are of such importance to mathematics that their inverses that reverse their action are known as logarithms. So real quick, let's just review. Remember what an inverse is. An inverse is a reflection over the line y equals x, or where you switch the x coordinate and the y coordinate. So we can say this is a reflection over y equals x, which is actually, if we look in this first graph here, that is y equals x. Okay? It's also where you switch x and y and solve for y. Those are the steps when we did the equation of an inverse. Okay, so those are the two things that we have to remember. So in number 1, it says that f of x is equal to 2 to the x is shown graphed on the axes below along with its table of values. Part A wants to know, is this function 1-to-1? And we never talked about 1-to-1 this year, so we're going to go ahead and skip this question. Okay? Part B says, what must be true about the inverse of this function? Okay. So this kind of goes hand in hand with part A, so we're going to go ahead and skip that as well. Okay. Part C, that part we can do. It says create a table of values below for the inverse of f of x equals 2 to the x and plot this graph on the axes given. So remember, because they're asking us to do an inverse, all we have to do is take our x and our y and switch them. So all the x's are going to go in the y's. Okay? And remember that that's the notation for inverse. And remember, to get an inverse, all you do is switch the x and y. So all of our x's are now going to become the y's. So -3 was an x. -2 used to be an x. -1, 0, 1, 2, 3. Now they're going in the y column. Remember, f of x is a synonym for y. Okay? And with the little -1, that's the inverse of it. All right, so then all my x's are going to come from what used to be the y's. So this will now be 1/8, 1/4, 1/2, 1, 2, 4, 8. Part D says, how do we know graphically that these two functions are inverses? Well, we didn't graph it yet, so we're going to have to go ahead and graph it. So if we go ahead and graph 1/8, -3, 1, 2, 3. I don't like how I put that point so close to my y-axis. I'm going to go ahead and do a smaller dot because I have a feeling that I'm going to be getting closer to the y-axis this time instead of the x-axis. 1/4 and -2. 1/2 and -1. 1, 0. 2, 1. 4, 2. 5, 6, 7, 8, 3. All right. And there is f inverse of x. Okay. So part D says, how do we know graphically that these two functions are inverses? So we're going to go ahead and mention what we talked about before. It's a reflection over y equals x. Okay. Part E says, write an equation for the inverse. So if you remember, all we have to do is take the equation, and the equation from up above is f of x equals 2 to the x. Okay? Remember that the first step is to switch x and y. So remember that this is actually y, and so if we change that big Y to an x equals 2, and we change that x to a y, step 1 is done. Okay. Step 2 is to solve for y. Except, how do we do that when y is an exponent? We don't have a process for that. So, like if it was 2y, we could divide by 2, but it's 2 to the y, and that's going to be different. And so that's why we actually need our logs. Okay, so with our logs, they help us solve for exponents. Okay, so that's what you have to remember. Anytime you need to solve for an exponent, a logarithm will be involved. And it's not that bad, it's just a change of form. And then it's another change of form to put it in your calculator. So it's not terrible. You just have to get used to changing this form. All right. So when something is an exponential form, you have what they call your base. Okay. And your base is raised to an exponent. And that is usually equal to something. And they call that something a number. All right. So they'll shortcut this. B to the E equals N. And some people will call this Ben form because it spells the word Ben. Okay. Some people will refer to this form as exponential form. Okay. Just know that it's base to the exponent equal a number. Okay. When we're in log form, we literally need the word log. So that's a huge difference. Okay. If you're in log form, you literally see the word log. Okay. On the end of the word log, there's a subscript. Okay. And that subscript is the base. So you can see where they're both forms have a base. All right. But when you're in log form, it's on the end of the word log as the subscript. Okay. Next, on normal level comes the number. Oops, I spelled number wrong. Let's try that again. I forgot my M. Number. And then it's equal to the exponent. All right, and so if I rewrite that one, that's log with your base, then your number, then equals your exponent. All right, so those are the things to remember. This is exponential form. This is log form, okay? When you're solving for an exponent, you need to go from exponential to log. All right, so now we're going to go back to thinking about that inverse question, okay? So remember, we were stuck right here. We had x equals 2 to the y. And so now we're going to go ahead and want to solve for y. Y is an exponent, therefore we need to go to log form. And so what we're going to do first is we're going to identify our parts. Our b, or our base, is the number 2. Our exponent is the y, and the n, which is what they call the number, is actually the x. I know that's weird. All right, and so now we're going to go ahead and write the word log. We're going to give it the base, which is 2. We're going to give it the number, which is x, and then we're going to put the equals, the exponent, which is the y. And now take a look, guys. It's in y equals form when we transformed it into log form. Okay, and so this is what the inverse of this is. Okay, so this is exponential, and its inverse is a log function or a log equation. Okay, and so I know that'll take some time getting used to. Okay, but we're going to practice on the next page, and I'll see you guys there in the next video.